Hello, my name is Trinity Watts, and today I will be going over the Hardy-Weinberg Equilibrium theory. The main idea behind the theory is that genetic variation will remain constant if there are no disturbing factors. So, for this, I'm going to pull this over more. Some of the core assumptions are that the population would be infinitely large, genotypes do not differ in fitness, there is no mutation, mating is random, and there is no migration. So essentially, all of these assumptions are they're impossible. They're not going to be able to happen. So for example, with the population is infinitely large, populations will have an end. They're finite, they're going to end. Genotypes, they do not confer in fitnesses. Natural selection imposes some differences. So there is no mutation. Mutation rates are available. They have been studied. Mating is random. Mating is assumed to be random at a certain point, and migration, that can be true sometimes. So the Hardy-Weinberg equation is used to calculate the genetic variation of a population at equilibrium. So here, I'm gonna show a bit of this equation and kind of how it works and what's involved in it. So P plus Q equals 1. That's how to calculate the allele frequency, which is used to get the second frequency, which is genotype. So P plus Q must equal 1. P is the dominant allele frequency, Q is the recessive allele frequency, and then you will use these to go over here. So for P squared plus 2PQ plus Q squared equals 1. P squared is homozygous dominant, 2PQ is heterozygous, Q squared equals homozygous recessive, and then of course this whole thing has to equal 1. So a question that I'm going to use to show an example of how to use the equation. It is 500 frogs, 375 are dark green, the rest are light green, and you have to solve to get the genotype and the allele frequencies. So we have to use the information that's given, and we can't just assume anything. So since we know that taking these two, I'll be able to get the Q squared, we're going to go ahead and solve and do it that way. So I'll take 125 divided by 500, which will give me 0.25, which is Q squared. And then taking this, I can solve for Q, which will be the square root of 0.25. So now I get 0.5, which equals Q. Then we move over here. Now that we have Q and we know that P plus Q equals 1, I'll be able to solve to get P. So P plus 0.5 equals 1. Then we'll just take the other 0.5 and then that'll be the P. So then, I'm gonna move a bit closer. So then we get to move to step 5, and then we get to put the whole equation together now that we have all the pieces. So this will be 0.5 squared plus 2 times 0.5 times 0.5 plus 0.25 equals 1. And then that's how you will get the homozygous dominant, homozygous recessive, and the heterozygous equations. Thank you.